All right, everyone, how are we doing today? So week 2, day 1, math video for the day. As you can see, it's going to be area. Now, something I want to point out, let's make sure that we're all still reading this document. It does provide some explanation. It even gives you a little bit of an enrichment activity. You all have a copy of this. If you don't, please let me know. I will forward that to you and get the instructions. I won't waste time here reading it. I want to get right into it. So area of various figures, right? We call these two-dimensional closed figures or polygons. So we're looking at a number of those. You will find attached to this video a copy of the quadrilateral hierarchy. You may have been lucky enough to have grabbed that before you went home, but just in case you didn't, you'll find a copy of it here, and it'll help you kind of jog your memory on that. Remember that a parallelogram is any four-sided closed figure or polygon which has two sets of parallel lines, okay? And we can find the area for parallelogram by multiplying the base times the height, right? Height is always the distance between the bases. A triangle is always formed by half of a parallelogram. So the trapezoid is the broadest distinction of quadrilateral. A parallelogram is a type of trapezoid. And when we look at a rectangle, that's a very special type of a parallelogram. Square is a special type of a rectangle. The one that I'm noticing is missing on this is the rhombus, which is basically, imagine I took the square and offset the rectangle. Remember, square is at the bottom of that hierarchy where we find it coming from both rhombus and from rectangle. And again, you'll see that that'll be attached to this post as well. Okay, getting into it, it's relatively straightforward. You have all of the formulas here, and we're calling them formulas. Remember, these are algebraic equations. You have area, or A, equals, and then in the case of a rectangle, it's length times width. Parallelograms, base times height, 1/2 base times height for a triangle. Trapezoid is the longest, but it's just the same. Remember your order of operations. Area equals 1/2 times the sum of the bases, base 1 plus base 2 times the height. I would avoid this. This was a resource I actually created with, or another one of my teachers from another building created. I would avoid that. We haven't really practiced that, but it does amount to the same thing. These are the sum of the bases, this is the height, and then she was just dividing it by 2. Alright, so getting into it, relatively straightforward. Though the first one is actually the most complicated, and you'll see I made an important note here. Very important note. It says find the area of the shaded region. There's nothing shaded in this image. It's a copying error. So this part right here is shaded all around that. This middle part is not. So when you're finding composite figures, what you're doing is either adding different figures together, in this case triangles and rectangles, and then subtracting if you need to, or adding to figure them out. In this case, you're going to find and I'll tell you right away, you're going to find the area of this rectangle, and then you're going to find the area of this rectangle, and you're going to subtract this from this, and that'll get you your answer. In this one, you're going to do the same thing, except you have triangles, you have a trapezoid, right? You have a number of figures, and take a moment on this one. This is going to take you a second. So follow along with this. This will explain everything that you need to do. When we get to area of parallelograms, you can see that this is this page is much easier than the previous page. You're just looking for the area of parallelograms. Remember that squares are types of parallelograms. Area of triangles, same thing. Remember, we found the area of a parallelogram and then cut it in half, even if we imagined that parallelogram. A triangle is just half of a parallelogram. You can always double any triangle, right? Create an image identical to it, a congruent image, excuse me, I couldn't find the word. Create a congruent image and just flip it up and create a parallelogram. And another page on area of triangles, you can see even if they're extra tall. We don't even get into types of triangles here. There's one more page I wanted to talk about. Trapezoids, be very careful with your formula. Area equals 1/2 times the sum of the bases times the height. Okay, follow the order of operations. Another area of trapezoid problem. Do your work on a separate sheet of paper, keep it neat, all the things we've been practicing. And then this last page, I want to take a moment. Remember, any regular polygon. Regular means that it has equal side lengths and angle measures. So in the case of this 1, 2, 3, 4, 5, 6, we call this a hexagon. This is a regular hexagon because all of these side lengths are the same and all of those angle measures are the same. When we look at this same thing right here, this is the same shape. What they're showing you is that you can split that into congruent, meaning equal triangles, and take those congruent triangles and add them up. So if I can find the area of one triangle, like we can do here, using the formula for area of a triangle, I can multiply it by, in the case of a hexagon, 6. Now this is a regular pentagon because 1, 2, 3, 4, 5 sides. I would need to figure out what the area of this triangle is and multiply it by 5. Same thing down here, but for all these different shapes, okay? All right, and that pretty much does it for math day 1 of week 2. Again, if you do have any questions, let me know, and I will see you guys in the classroom. Thanks.